Okay, for just the recording, this is the P&T competition. We are going to be covering data extraction and nested knowledge today during today's webinar, and we're going to start out with a review of the initial stages of working in the software, so literature search and screening. I'm going to go ahead and share my screen. Let's take a look at the training ground that was built prior to kind of starting. So we'll go into this project. Just as a little reminder before we actually begin talking about the screening process, I want to encourage everybody to continue if you're setting up your organization and if you're getting ready to kind of participate in the competition for the first time. I want to remind you that you are able to go in here and create the organization by just, getting started for free, clicking here, first and last name, hit the continue and accept the terms of service. It'll ask for your email and a password. You can set up that account and then you can verify your account. So that's just the simple sign up process. And if you're looking to create your organization for your institution, you can go into your name in the upper right hand corner, click on organizations and create that organization here. Just a reminder that you're able to complete all those steps. Just feel free to email the support line and let us know when you've done so, and then we'll be able to mark you as verified, and that's how you'll be able to get access to all of the AIs and all of the different features that I'm going to go over today. All right, so here's my homepage. We're going to go into this project, and what we're just looking at is going to be this first page, the literature search. This is the way to get abstracts into your project, how you are able to conduct a literature search, whether that's the manual literature search or by using the AI Smart Search. The manual search is going to just involve clicking Add Search. You're able to go in and paste a PubMed query into here. It'll be a direct match on what you'll find in PubMed. This is through an API system that connects directly with PubMed. And then once you hit add, you'll see that the search runs, and the abstracts come through. Same thing with the file import. You're able to go in and, upload a file of interest. For this particular project, and I encourage all of you to, try this feature out, you are able to go in and create a smart search, which is what we did here. If you click on the smart search function, the first thing that it's going to ask you is going to be, what is your research question? This is not the research question that I originally put in. I put in something a lot more simple than this. It went on and it rephrased this research question to make it specific to advanced or metastatic non-small cell lung cancer. And then if I hit refine, I can go in and make this even more targeted to, specific types of studies or, a particular subset of disease, or even down to the location that the study took place in. If I click on this view recent, we're going to take a look and we'll see that it was able to come up with 3 queries for me ranging in scope. So, down here, it's giving me like a very broad search, 5,000 results, humongous search. And then we have query number 1, which is 1,000 results, much more targeted, much more narrow scope. So once we hit finalize, we're going to see that, it goes in, it adapts the query. We can go in here, we can explore, we can also change the keywords if need be. We can also narrow it down by the date. And if I were to run this search right now, it would import, 1,116 results. Okay, so that's literature search, a quick overview of kind of what's expected and how to create the literature search and how to run it. And this is how the studies come through. Can I take any questions on how the literature search is run or anything that I just went over? I imagine that most of the people on the call today have already kind of played around with this step, if not, completed this step in terms of their project. Just because this is going to be one of the first steps that you complete to begin your evaluation process. And oh, okay, it looks like we do have a question. Yeah, Paula, I hope I'm pronouncing that correctly. Feel free to go ahead.
Yeah, so just so I'm making sure I understand, you would go to the nests first?
You would go to, yeah, this blue nest button. It's going to take you to your homepage. So these are where all my projects live. You can see I've got thousands of projects in here. You guys might just have, one project, or you might have a few, depending on how many your teammates have created. But yeah, to begin, you'll just hit that blue nest button. And if you have an existing project, you can go into, the project that you've created, or you can also just create a new nest in this blue button right here.
Okay, yeah, thank you.
Yeah, absolutely. Good question. Other questions that we've got? Okay. Then let's go back into this project and let's take a look at what happens when we bring in these 428 results. The next step that we're going to take a look at is going to be the screening process. Now, when I was talking to Kevin and I was touching base with some of the organizers of the P&T competition, they did let me know that this is going to be systematic literature review. So I've configured the nest for dual screening. In nested knowledge, there are several screening modes depending on kind of what your aims are, what evidentiary standard you're trying to adhere to, or even what study design you're pursuing. So, because this one is a systematic literature review, I've configured it for dual screening, and I encourage all of you as you're setting up your projects for the screening, you'll first go to the settings, and you're going to scroll down to where it says screening. This is the settings for screening. And it's going to ask you, do you want this to be a standard or a 2-pass? Meaning, do you want this to be a 1-level screening mode, or do you want this to be a title abstract and a full text screening mode? You see, I have configured it for standard. I don't think for this it's particularly necessary to configure it for a title abstract and a full text as a separate review. And then I've also configured it to be a dual screening process, meaning that there are 2 humans making a decision on each record, and then we have a third party adjudicating that is going in and telling me, is this the final decision on a given study? So they're making the final decision based on the 2 screenings that have been performed. Those are the 2 broad modes that are offered, and depending on kind of what your aims are, you can configure these as necessary, although this is probably the configuration that I would say is most common when going through like a systematic literature review, the kind of what you guys are aiming to do. Now, in Nested Knowledge, we also have some AIs for the screening. The one for the dual screening is called Robot Screener. So if we scroll down, we're going to see that we have the ability to turn this on. Down here, we'll see that, I can turn on Robot Screener. I can also view the screening model at any given point in time. If you are following along with me right now, you might see that this is grayed out. And Robot Screener has a few caveats in order to be able to turn it on. The main one being that in order to, train the model and get the parameters for which the robot and the algorithm are going to perform on, you're going to have to screen 50 studies, and they will have to be dual screened and adjudicated. So, you and a colleague can go in, screen 50 studies in the dual screening mode, meaning that, I would go in, I would make a decision. Maybe this one does not report. Looks like it actually does not report on CLC. It was on a rare brain cancer. Then another colleague of mine would go in and make another decision on this abstract. They wouldn't be able to see that I excluded this for not being reporting an SCLC. And then finally, I would go in and adjudicate the difference. Once you've done that 50 times on 50 abstracts, you'll be able to come in here and you'll see that all of a sudden no longer is is it me and Kevin doing the screening? It's actually Kevin and the robot doing the screening. So really beneficial AI. It does allow you to kind of get one researcher out of the process of doing the screening. So you're doing it twice as fast just because you're taking one human out of the equation. But you do still have 2 human reviewers, one being the decision maker, one being the adjudicator that's making the final decision as well. Okay. Can I answer questions on the screening process? And I encourage the team at AMCP, if you encourage another screening mode, feel free to let me know. if there are questions on any of the other screening modes, also feel free to let me know. But that is just a brief rundown of the robot screener and how this particular AI works in the nested knowledge interface. And then as I'm just awaiting questions on the screening, I'll also go through very quickly how to do the adjudication as well. So if let's say that I've screened, my almost all of my studies. I've screened, 204 studies, and they're ready to be adjudicated. Like I mentioned, we're going to go in here. We're going to see, regardless of whether that's the robot or two of my human colleagues, we'll see the difference here. And I'm acting as the adjudicator. I can decide which one of these to actually use. So, I think I agree with Kevin. It's not a randomized control trial. I'm going to use his decision. If I completely disagree with both of these decisions, I can also choose my own decision down here. And we'll see that, I have the ability to go in here and select like a different decision altogether and make that the final decision. If you have a large number of studies and you want to auto adjudicate, based on, there are agreements. So these are instances where the robot and the human agreed. They both said to exclude or they both said to include, or maybe two humans agreed, same thing. They both said to include or they both said to exclude and they agreed on that. You can go in here and hit the auto adjudicate and it will ask you, do you want it to be any or exact or shared? This means that, do you want the exclusion reason to just be any? Do you want them to be an exact match? Like, do you want them to both have the exact same exclusion reason, or do you want them to be shared under some sort of PICO criteria? The exact option is going to be difficult for you to utilize in the robot screener interface just because the robot will always only say exclude or include. It does not give a reason. So you're going to want to select any just to be just to make sure that the human's reason is the one that's being used. Okay, I will take a quick glance to see if anybody has any questions. Doesn't sound like it. I hope that was clear. This is definitely one of the more complicated AIs in the system, just because it does involve a training of an algorithm and then kind of being able to measure how that performs. But it is beneficial just to be able to finish that dual screening in time. And I do encourage you guys to go into the settings and kind of configure your nest accordingly, just in accordance to systematic literature review best practices and guidelines. Okay. All right. So now that we've kind of done a great refresher on the initial stages in the systematic literature
Renata,
review.
there was one
Yeah.
question. Sorry.
Oh, yeah. Okay. No worries.
Sarah?
Feel free.
Hi, so just quickly, what does shared under PICO criteria? PICO is what we decide, so what would that do?
Oh, okay, great question. So you can see that my exclusion reasons here have been configured, and I'll cover this too. So as we're setting up the screening process, we can go into the little gear icon here and set up exclusion reasons. You can see that my exclusion reasons here are actually set up in a PICO framework. So I've got population, but then I have all these reasons under population. I have intervention, then I have all these reasons under intervention. So the adjudicate screening, this option where it says shared, means that they just share one of those headers. So for example, they might not be an exact match, but they both fall under population, for instance, or intervention. So that would count as an agreement at that point, and you would count it as and you'd be able to auto adjudicate it under the shared inclusion criteria or the exclusion criteria. Great question. Other questions I can answer on this process of robot screener and dual screening? Okay. Perfect. So the main topic of today's session is actually going to be on the data extraction. And I mentioned before that the data extraction, it can be hard regardless of what system you're using, whether that's an Excel or whether that's a system like Nested Knowledge. And that's because it requires, some degree of design, being able to go in and say, well, this is kind of the conclusions we're looking to make on a given topic, for some evidence landscape or some body of evidence. So today's topic, we're going to be talking about the tagging process. I'm going to go into the gear icon next to tagging, and let's take a look at what this looks like. If you're following along with me, it's very likely your screen is going to be blank, completely blank. But I did want to configure a few variables just to be able to show where we're going and what we're doing. So here's our first initial kind of variables that I've laid out, and you can see that I've kind of structured it so that we have these three different branches that we have variables coming off of. If you can visualize an Excel workbook or even some sort of data extraction grid, you might be thinking about how to section out variables so that they are all kind of grouped together and they're reflecting a certain aim or a certain goal. So that's what I've done here. I've put all of the measures that are looking at study details under a kind of a common header. I've put all the clinical evaluation measures that we're going to configure under a single header, and then a few economic evaluation measures, and I kept them separate. How this is going to export is the main reason why I've done this, but I've also done this for ease of collection of the data. So, if we're thinking about the Excel output, these are all going to be separate sheets inside of a larger Excel workbook. And I encourage you to structure it kind of similarly so that you're able to kind of group all the variables together that you might want on a single Excel export. To begin here, I'm going to teach you guys how to create a new tag. So I keep referring to them as variables, or I would even call them like columns in an Excel. That's pretty much what they are. They are like a variable that can be collected for a full text in the software. So let's go ahead and learn how to create one. You'll go ahead and hit create new tag at the top here, and then you'll put in the tag name. So for example, if I'm looking for my study details, I might be really interested in something like, what was the population that was being studied. I expect that a lot of these are going to be like NSCLC, metastatic or advanced cases. And so I really want, either one of my colleagues or an AI to go in and collect the population. I can hit save, and we're going to see that the variable appears. Oops. There we go. And then I'll hit the question type, and that is going to be a single apply question. And oops. Sorry, everybody. It's going to be a single apply question. And the reason, I'll take a pause here, this is going to be kind of like one of the first decisions you'll have to make as you're configuring these variables. So the difference between a single apply and a single select and a multiple select is going to be how you want the variable to be reported. So a single apply question is going to result in just an extraction, like a sentence being collected from the full text. It'll go in, it'll pull that sentence, and it'll say something like, the population that was being evaluated was, stage 4 metastatic NSCLC patients. For the other two, single select or multiple select, you can think of these as like multiple choice questions. So a good example of a single select question would be something like study design, where I just want either a researcher or the AI to select from a dropdown. Just select one choice and tell me, is this a randomized control trial, a retrospective cohort, a case study, etc. An example of a multiple select question might be something like adverse events, like select all the reported adverse events from a drop-down menu, and you can select more than one. So those are the differences between these three question types. I will say the vast majority of your variables are probably going to be single apply questions, just simple fill in the blank questions, just fill in the information and give me like a sentence or a number or some sort of measure as to how this was being measured in the study. So I'll configure it as a single apply, and then I'm going to just move it underneath the study details option. And then we see that that variable is just going to stay there. Okay. Let's do a few more. I'm going to do a few more on the study details, and then I'm going to talk a little bit about, why some of these are square and how to configure ARM level information as well. So another variable that we might be really interested in is going to be like time frame. Let's make a new tag, and I'm going to name this time frame. Question type is still going to be a single apply. I just want it to collect a single sentence, and I'm going to just move it under study details, and that's all. We know that they are configured correctly because we see it's a question and it's a circle, and at any given time I can go in and review these. Now the question here is really important. So if I go in and I'm looking at my country variable, for example, I might want to go in and say, what is the country of interest? And this is going to make the AI a little bit more targeted in how it's collecting the data. It's kind of like typing a prompt into GPT. That's almost exactly what it's like, because the adaptive smart tags that we're going to be using today is powered by GPT-4. And so this is a really good way to give it an instruction on how it's going to, be collecting this information. You can tell it things like, state it in one sentence. You could tell it, give this as a bullet pointed list. You can say, report it from the conclusions, any sort of instruction that you might inform a researcher, it will likely be able to understand. So you can use this question area to kind of give it additional instructions, and I encourage you guys to do that as you're configuring your variables. It will make the AI much more targeted and that much more powerful in getting the output that you are looking for. Okay, let's take some questions. Any questions I can answer on the study type and the single apply questions just at the study level? So the variables that are just reporting, like just broad information about the study and how it's being conducted. Okay. Let's talk a little bit about some more complex variables. So, clinical evaluation measures. That's interesting because you guys might be looking at something like progression-free survival if it's an SCLC, or something like mortality, or something like adverse events. Like what was the percentage of adverse events that were being that was experienced by the patients. Things like that would be clinical evaluation measures or outcomes. And what's interesting about them is that they don't occur at the study level. These are variables that are at the arm level. So they're at the level of how was the placebo being, how did the placebo population fare versus how did the treatment arm fare. And I'm actually going to go to my tagging module and show an example of what this clinical evaluation measure could be before we talk about configuring them, just so that everybody is on the same page with kind of, what differentiates these variables from these variables that I'm talking about here. So let's go to the tagging. And I configured some variables ahead of time, and I ran the AI just so that I could show, how this is going to behave. And so here's my full text. We've got it here. And if I go into the study details, like my first, kind of page that I've got with all the different variables, we'll see that it didn't find what country it was conducted in, but it did find the publication type. So if I click on this, it will show me exactly where it got this information from. So the study is a randomized double-blind phase 3 clinical trial. It got it from this sentence right here. And this is how it's being reported because I've configured it as a single apply question. Same thing with data source. It's collected from right here. And we see that it's kind of telling us like what's the data source, where the site's from, and then what was the population as well. So this is how it's performing at the study level. Like I mentioned, all of these variables are kind of just describing how was the study conducted, what was the methodology overall, how is it being done. Um, for something like the clinical efficacy outcomes that I was talking about, we're going to go to one of our first tables and I'm going to kind of explain how this works. So we can see that in table number 1, these are baseline characteristics and patient demographics. And we see that, curiously, these are split into 2 populations. So this is kind of what I'm talking about when I say arm level information. We see that, this group was being given this therapeutic versus this group being given, a reference medicinal product. So I imagine that's just another name for placebo. These are not at the study level. These are very specific to a certain population or to a certain arm, and we see that these variables are being reported differently depending on what population was being studied. So, for example, if we were looking at something like mean age, these 58 participants are going to have a different age range, mean age in years, than this cohort in these 59 patients and how they're being measured. And we see that they do differ. So in order to collect that information and to get a really robust extraction process for variables that are configured like this, we actually need to configure it in a table format too. So that's what we're going to do. We're going to go in and configure a few variables that kind of go along with this process. So let's go in here and let's go back into the tagging now that we've kind of centered our goals, and let's go ahead and configure some clinical evaluation measures. So to start out with, I'm going to do a baseline characteristic just like we saw in the first table, and I'm going to keep it really simple. I'm just going to configure it to be age. So same thing, we go in, we hit save, and I'm going to change the question type to still be a single apply. We still just wanted to fill in the blanks and collect a sentence or a number for us. And I'm going to go in here to the content mode, and I'm going to change it to be table. And the first column, I'm going to name this to be arm. For these tables, the first column will always be ARM. This is really important. This is just so that you're able to define, how is the data being segmented out? What is it being, segregated by? And in this case, and probably for all of your tables, it's going to be ARM or, some sort of like cost, for example, to kind of separate out the 2 different groups that are being studied. So I'll hit add, and then I'm also going to do something like, let's do like mean age. We'll do median, and we can do IQR. And yeah, that's how I'll leave it just like that. And I'll just do end so that we can get kind of an understanding of how many people were evaluated. If I want to change this around, I can change it by just moving these. I can also rename them if I need to, edit them at any point. And then I'm just going to move this table under clinical evaluation measure. So that's an example of how to configure like a baseline characteristic. If you're doing NSCLC, you might be interested in something like, gender, how many males versus how many females. You might be really interested in something like smoking status. Probably a lot of these studies are going to report, whether they were former smokers or whether they're current smokers, things like that. So those are all examples of baseline characteristics that can be reported. And I would probably, we'll tackle that as we kind of talk about some outcomes. Okay, questions I can answer on the difference between a study level variable and an arm level variable. Okay, right, let's go back to here and let's actually do an outcome now. So I'm going to create a new tag and I'm going to keep this under clinical evaluation measures. And this time I'm going to do progression-free survival. same thing. It's still a single apply question. I'm going to kind of give it some information. So, how many experienced progression free survival. And then I'll change this over to be a table. And the first column, again, is going to be arm. And my second column is going to be something like N. And then I'm also going to do something like maybe the number of events. So I can say percentage, for example. And then I'll also do check back out that first table, maybe something like a time frame. I think this is a really important aspect of a lot of these studies is going to be the time frame, because you can imagine progression-free survival could be measured at 3 months, 6 months, 9 months. This is a long-term disease state, and so time frame is probably something that's really important for this particular measure. And then I'll move that here, and I would say that that looks good to me, and I'm going to go ahead and move that under clinical evaluation measures. Okay. Lastly, I'm going to talk about like economic evaluation measures. I am a health economist and an epidemiologist by training, and so I imagine that you are going to be looking at the cost information if this is going towards like an AMCP dossier example. And so we can do some economic evaluation measures. I did configure one here for cost inputs already, and here's an example of how you can structure this. So you can do like the type of cost, the cost measure, the cost description, the cost value, and that those are just descriptors, kind of, how was cost being, spoken about, and kind of what cost, like how were they being broken down. But if I want to take it a step further and do something like for a cost effective analysis, I can also create a new tag, and I can call this something like, let's do economic data, and I can just say something like, change this to be a table, and then I'll kind of do the same thing, type of cost as the first one, and then I can also introduce concepts like, ISO ratio, and then maybe something like a cost measure and currency. All right, so that's a nice little kind of guide as to how to configure these variables. And this is just an example. I imagine your hierarchies are going to look a lot different than this. They'll probably be a little bit more involved, and you might even have more sheets than I do here, just to kind of give you an idea of how to design like a very simple hierarchy and a data extraction grid. Now, to take it to kind of like the AI portion of this, let's say that I've configured my hierarchy and I'm really happy with it. I think I've done a really thorough job, and I've got all the variables that I think I'm interested in capturing. What I'll do is I'm going to go into this adaptive smart tags, and I'm going to decide that I'm going to run it on the full text. I could also run it on the abstracts, but the full texts are going to give you a much more detailed extraction. I only want to compute this for the included records only, and I want the annotations to be required, and I'm going to hit apply. If I hit recommend, I'm going to have to go in and QC these one by one, and so I just want to see what the initial outputs are going to be, and I'm going to hit apply so that I don't have to necessarily go in and QC everything one by one for this first initial run. Okay, so while that's generating, I do want to cover a few things in the study inspector, because I imagine that you all are still in the screening process, or maybe you're just performing the literature search. There might be like varying degrees of how the different teams are working in the system. So I'm going to let this run, and I'm going to talk a little bit about the study inspector and how to get the full text into the system while this is running. So let's go ahead and exit out of here. I can still check and see if it's running by clicking this 3-line menu at the top. It's at 10%. It's going to run probably in the next 2 or 3 minutes. So let's talk a little bit about how to get the information in. So if I go to the study inspector, this is a really powerful page. This is a page that contains all of the studies that I brought in through the literature search, all 428 records, regardless of whether or not they've been included or excluded. There's a lot of things I can do in here, so I can filter to subsets of data depending on different variables and different steps that have been taken in the platform. I can also examine the studies by hitting the Explorer function down here. So this is telling me, out of my 428 records, what are the PICOs? What is the study type? Like how many in vitro studies do I have in comparison to randomized controlled trials? I can also look at the location. So really powerful kind of view on how this is like what studies are contained within this body of literature. For our purposes today, I'm really interested in the studies that are included because I would like to bring in the full text. So I'm going to add a filter and a really simple filter for the final screening status. And I'm going to select the status of being included. So it means that they are, they've been designated to be included after the full dual screening process. So I'll filter to those. And I would, since these are my included studies, I really need the full text to be able to perform the data extraction on these studies. And if I click on one of them, we'll see whether the full text is available or not. You'll see that this one is unavailable on paywall, so it must be behind a paywall. If I want to also check and see how these studies are, like the original source site, I can also click on this, or I can click on this little drop down and it'll take me directly to PMC. And here's the study. Looks like there actually is a PDF. And so if I download this, I can bring it directly into the system. Let's go ahead and do that. I can actually just drag it into the full text upload, and then here we go, the PDF appears. And so that's the way to do it manually. Now, if I want to do it with, kind of like an AI assistance, I can go in here, I can perform a bulk action on these included studies. I'll select the bulk action for document import, and then I will say import from unpaywall, and I'll hit apply. And what this does is it searches unpaywall, which is a database of freely available full text, and if it finds any of the matching records that I've filtered to here, my 21 records, it will bring it directly into the system so that I don't have to go and source the PDF myself. So if you're at the stage where you're finished with the screening process, I recommend performing this step so then you won't have to actually go in and find the PDFs yourself. You can just see how many you'll get through this document import step. Okay, questions I can answer on this part or anything that I've discussed so far. Happy to answer any of your questions, even if they're specific to your project. Feel free to let me know. I think that that's a great way to learn, is having some like applied examples. So feel free to let me know. Raise your hand, or you can also just unmute. And we're just waiting for the AI to finish running. It's actually done. But I still encourage anybody, if they've got questions, feel free to go ahead and ask. Okay, this one it didn't run on because we actually just brought this PDF in while it was running, so it didn't get the same treatment that the others did. So let's skip this one. Let's go to the next one. Here is our one of our randomized controlled trials, and we can see that this didn't find any cost information. That's probably what I expected, because this isn't a cost. This has no cost information. It's a randomized controlled trial, and but let's say that I was wrong and there is information missing. I could go in here and I can type it directly in as well. So I could say something like, direct cost. And I could say, cost measure is like USD, and then, I can, and so on. So I have the ability to do this completely manually. I want that to be known as an option. You don't have to utilize the AIs, but let's go ahead and see what the AIs did, and we can kind of see how it performed. So here's our study level characteristics. We see that it did find the country, Russia and India, and we know that that's right because it's reflected in the sentence right here. Publication type, we went over that one. Data source, it didn't find. This is not an RWE study or, retrospective cohort or anything. So the data source is actually, this was actually just, an actual randomized control trial. So I'd say this is correct. No data source. Study objective, grabbed it from this abstract that we see here. So we kind of see how it's performing. And of course, if we wanted to make this more targeted, I really encourage you guys go ahead and change the prompts here to be kind of what you're looking for, whether that's a brief summary of, the variable, or whether that's, a really specific population. So you can even say, extract the information on the advanced metastatic non-small cell lung cancer population, things like that. You can definitely give it those instructions. So this is how the study level characteristics look. And then now let's take a look at the clinical evaluation measures. And wow, this did a really great job. And we can see for something like age, it pulled it from table 1 that we see here, and it was able to understand, the specific arm. So we have the arm for CRC, and then this is the specific therapeutic that they were given. 58 people were given this drug, and then the mean age, it captured that, and then we didn't have median age or IQR. So if this was me, I would go in and I would just make an adjustment. So I might go in and click this header, and I might also include standard deviation as a measure that I want to also report, and then I can move that to be here next to mean age. So, that might be something that you do after your first initial run. You're going to probably have to run this a few times because, you'll make little tweaks and you'll decide, is this giving me the results that I want? And then you'll see it doesn't fill in automatically. We have to go in and run that adaptive smart tags one more time in order for it to kind of compute and collect the information. So I'd say this one did a really good job. And then progression-free survival, let's see how it did on that. And so it's getting it from table 2, this table down here, and then we see the different arms. The time frame was 6 months and 9 months, the N, and then also we're seeing the percentages of how many people survived and experienced progression-free survival. So this is the difference. You guys can see like how the data is being segmented. These are obviously by the arm, or how the treatment that's being given, the population that's being studied. These are all different ways to segment the data and to kind of give it an independent variable, versus the study details, where we're looking for things like that are at the study level, that are just describing what was the methodology, how was the study conducted, etc. Okay. Any questions that we can answer on the results, or that we can talk about? Was it what you expected? Was it not what you expected? Anything like that?
I just have a question. So for each individual article, a new set of data is created, and then that's by AI. And so is there a way for us to collect all of them, or is that too complicated?
So you're saying collect all of them as in like summarize the information, or
Yeah.
like export the information? Okay, great question. This is very timely because this is our topic of conversation next week. So to export the information, we can go in and create, and I'll just kind of give a precursor to this. Like I said, we're going to be going into depth on this next week. But if I want to go into the dashboard and create like a table, for example, I can do that by just clicking table. Let's say that I just want the clinical information, and then I can add a column here for whatever variable of interest I want. Let's just do age right now, and then we'll wrap the cells, and then we'll hit add, and then we'll see the information reported here. I think a lot of them didn't have full text. Yes, here we go. So, some of them had full text, but other ones were just completely blank because like they have no full text available. This is also a really great way to QC the data. So, if I was reviewing this and I was taking a look and I thought, okay, well, this Cass Lee Wall study has like like 5 arms, or it has like 6 arms or something. I might be interested to see like, what does this study actually report? And I can click on the study and it will pull it up for me and I can review here. I can also change things. So like if I saw something that was inaccurate, I could go in and change this to, report, a different number or something like that. So it's you're not you're not tied into reporting just what the AI says. You always can go in and edit these and just make them smaller. So you could actually go in and say like delete that and just say patients with non-resectable metastatic colorectal cancer, hit update, and it'll be there for you as your human response. Does that answer your question?
Yes. Thank you.
Excellent. Excellent. Other questions I can answer? Okay, let's do one more thing since we've got about 10 minutes of time. And I do want to save some time for a discussion. I'll also save some time to talk about the follow-up and the resources and information I'm going to send over. But the last thing that I'm going to talk about is the data extraction for just the abstracts. I think that this is a really helpful tool as you guys are going through the abstracts, like screening the abstracts and things like that, which is the core smart tags. We talked about adaptive, and the difference between the two is that the core smart tags are pre-configured variables that are chosen for you. We identified these 4 variables as being the most common variables that researchers are interested in during their abstract screening process. And so if we go ahead and give these a run, we're going to see that it just computes the results automatically for us. And I'll go ahead and hit apply. I didn't run the PICOS because this one does give quite a large response. I recommend this if you're not sure what outcomes you're looking for, and also you can kind of see like a giant output on what the populations were, what the interventions and the comparators were. So I'm not going to run this one, but I'll run the other 2 and I'll just hit apply. And something to know about this is that these are only available for the abstracts. So, this is, like I said, it's a really great tool for the abstracts. But, for the full text extraction, you're definitely going to want to use the adaptive smart tags. This is a much more powerful AI for the extraction. And then we see here, it created this like study type tree, and then it also gave me the study size and the study location. And it works the exact same way. If I go in here and I look at the study location, it classified it as India. And same with the study type, it was a randomized control trial, and it got it from this sentence in the abstract. So if you're looking for just like an easy way to get started with the extraction, you certainly can run this and see, how does your data compare based on like what this reports. And you can also see that it ran really fast. So I'm just deleting this. I encourage you guys, you can run it and then delete it, so that you have room to configure your own variables and do your own study design, because that will be really key as you go through this competition. And I'm going to go ahead and move this under my study details. Okay, we have about 7 minutes left. I'm going to take questions. Any questions at all? I know that this is like pretty complicated. I'm going to send over a guide to data extraction in the software and how it works, and it has some suggestions for you guys as well. We also are going to go over this again in the next call, so we'll do a little refresher again and talk about the variables and all of that. And in our next call, we're going to talk about exporting the information, which we saw a little precursor of today. Um, and I imagine as you guys are getting started, you will be referring to the documentation quite a bit. So if you click on documents, docs up here, it's going to take you to this page. There's a video guide and a written guide for every step in the software, including the tagging that I just went over. So if you click on this, you're going to see like a little presentation. I think it's like 3 or 4 minutes, and then it also has a full guide to everything that I just spoke about. All right, questions I can answer. Okay. And then Ebony, do we have anything else to kind of say from the AMCP side?
Yes, and we'll close us out.
Okay, excellent.
Thanks, Renita. I'm going to go ahead and stop the recording here.
Okay.